So what are we going to do now is I'm going to ask you some questions, and for these questions I want a discussion sort of thing to happen, discussion sort of thing, as in not with each other, but then you just think, analyze and try to answer. These all questions are from the topics which we have covered so far in the previous classes or whatever. Okay guys, what do you think element is? Having uniform distribution or having some sort of equality with respect to quantity, but in fact that is not. You are thinking of homogeneous over there. Okay, homogeneous and heterogeneous mixtures which you have learned in class 9, you must be thinking about it, but in fact homoatomic is entirely different. Okay, so well guys, coming back, let me tell you what is the answer for this question. The answer for this question is yes, homoatomic, that's true. If you have given the answer by fluke, yeah, don't need to be happy. But then if you already knew what homoatomic exactly is and you have answered the question, then that's fine. So well guys, homo, the term homo means similar. Atomic means atom containing. Any molecule which is consisting of similar atoms is called as homoatomic. Okay, so elements are homoatomic by nature. By definition, elements are the molecules which do have similar type of atoms in them. And to understand this homoatomic very well, let me recall one graph which I might have told you or which I might have drawn in the first or second class with us. Okay, so the graph, it's not a graph, it's a flow chart which talks about classification of matter. How many of you remember this? Matter, what is matter first of all? Can anyone in the class, what is matter? Matter is very good. Very good, very good. Yeah, matter is something which occupies space and which has specific mass. Matter is anything in the universe which has mass and can occupy space. Almost everything that we see around us except light, heat, energy is matter only. And this matter can be classified. This matter can be classified based on two ways. One is physically based on physical properties and second one is chemically based on chemical properties. Okay, so based on physical properties, how do we classify matter? Do you remember this classification of matter on physical aspects into solid, liquid, gas, and what are the remaining two physical states of matter? Solid, liquid, gas, and then after that it is plasma. Very good, Yashika, and before Yashika is Harshit. Very good guys. So the next one is plasma and later Bose-Einstein condensate. 5 physical states of matter studied in class 9 chapter 1. Yeah. So this is physical classification of matter. But other than this physical classification of matter, we do have another classification based on its chemical properties. Okay. When I say chemical properties, what do I mean? I mean the chemical composition, right? So when I say chemical properties, I mean the chemical composition or chemical reactivity, okay? And chemically, matter can be classified into two types. And some of you already have said this, appreciating you. Well, it can be classified into two types. One is pure form of matter and the second one is impure form of matter. But what is this pure form and impure form? This is also not something new for us. We have studied about it in class 9, second chapter. Is matter around us pure? Remember? Yeah? Pure form of matter and impure form of matter. Correct? Pure form is when you have a huge sample given and you pick any two particles from any corner and you end up finding similarity between both of the particles. Like if you have, just assume that you are playing in a room full of red colored balls, full of red balls. Now if I ask you to close your eyes and pick any two balls, can you be sure that you are going to pick red balls only? Can you be sure? I repeat my question. You are playing in a room filled with so many red colored balls, smaller balls, and I'm asking you to close your eyes and pick any two balls. Can you be sure that you are 100% going to pick red colored balls only? Yeah? Obviously yes, right? Because you have only red colored balls there, nothing else is there. And the balls that you choose, that you pick, close your eyes or open your eyes, but the balls which you pick would be red in color. They would be identical, right? So pure substances like that, you choose any molecules, they are identical. You don't find non-identical stuff. They are identical and we call it as pure. What is impure then? The other way around. Non-identical particles. Assume the same room you're playing with the balls. This time not only red, it's a mixture of red and green. And I'm asking you to close your eyes and pick two balls. Now can you be 100% sure that you're going to pick two red balls or two green balls? Can you be? Yeah? It's a mixture. It's a mixture randomly distributed. Right? We don't have a control over it. So we can't be sure that we are going to pick up identical balls. It would be red and green. Yeah. So such mixtures where you have non-identical particles is called as impure. Pure and impure. Okay. And this pure doesn't have any other term, but impure particles or impure samples can also be called as any idea? What is the other name for impure form of matter? Impure form of matter is also called as, let me see who answered first. Very good. It is Zubin. Mixtures. Impure forms are also called as mixtures, and if you remember guys, you have studied about these mixtures like anything in class 9, which are further classified into two types: homogeneous mixtures and heterogeneous mixtures. When I asked you the poll question, you confused homoatomic with homogeneous mixture. Remember? Yeah? Right. Homogeneous mixtures are also called as solutions, which have uniform distribution, cannot be filtered, particle sizes less than 1 nanometer. And heterogeneous mixtures are further classified into two types based on stability and particle size. Good, Adrita, good. One is colloid, the second one is suspension. So finally we are having three types of impure mixtures. Where did you study about these three types? Did you study about them first of all? Did you study about them? Yeah? Right, class 9, second chapter. Oh my God, it was too lengthy, right? You study about the properties of solutions, colloid, suspensions, and then you also study about how to separate them, examples, whatnot. So many things about this, isn't it? Now, we are going to talk about pure substances. Pure substances are the ones which have identical particles, and they are further classified into two types. Based on what? Based on composition. Okay, so these pure substances are the ones which have identical molecules. Remember this term, these are the ones which have identical molecules, not atoms. How many of you have a confusion with atoms and molecules? How many of you have a confusion with atoms and molecules? To some extent, you can be honest, your chart is highly personalized, only I'll be able to read them. Nothing to worry, you can just tell me. Okay, 2. And if you don't have a confusion, say you don't have, okay? Yeah? Very good. I love your honesty. Sort of. Okay, don't worry. I'll tell you what is the difference between atoms and molecules in a while. Okay? Yeah? So, pure substances are the ones which have identical molecules. Register this point in your mind. I'm going to ask it again. Okay? Pure substances are the ones which have identical molecules, not identical atoms. Identical molecules. Why molecules? What are molecules first of all? Let me tell you. Matter is composed of very finer particles called as atoms. This we know, right? Atom is the basic unit of matter, and this is something which is very finer, right? Very finer, and it can't be further subdivided into some stable substance, right? Like if you have a chalk, or if you take any matter that's around you, go on analyzing to the microscopic level. At the end, you get atom. Atom is also called as basic unit of matter. What is it called as? Basic unit of matter. Yeah, clear? Why? What is basic unit? Remember, in biology also you study, right? In biology you study that cell is the basic unit of a body or of an organism, right? In biology, the most basic stuff is cell. In chemistry, the most basic stuff is atom. Bio is living, chemistry is not living. Okay? Yeah? And now the same way, if I ask you, cell is also called as building block of life, as Swati have suggested. That's true. The same way I can say that atom is the building block of matter. Yeah? Studied about proteins. Did you study about proteins? They are made up of amino acids. Correct? Yes? Amino acids are building blocks of proteins. Small amino acids combine with each other form long polypeptide chains called as proteins, right? Same way, atom is the building block of matter, basic unit of matter. Okay, but unfortunately, atom is pretty unstable. Like it can't exist as its own. It is very unstable. Conditions applied, guys. Not all atoms are unstable. There are some atoms which are stable. Okay, so I can say that most of the atoms are unstable. Okay, right? Well, let me take a pause, a small pause. Is there anyone who's not able to hear me? Harshita, except you? Anyone else who's facing audio video issues? Arey Aniksha, no, only one. Anyone seeing two videos of me? You see only one video, right? You're not seeing me in two videos, right? Okay, Harshita and Anishka, quickly refresh the page and join. Yeah, right? Well, Ankit, you can't see me only. Please refresh. Guys, if you are not able to see me, if you are not able to hear me clearly, please do refresh and rejoin. And after that also, if your technical issue is persisting, immediately ping in the WhatsApp. My support team will reach you and help you out. Yeah, right? Well, so let's go back. Atom is pretty unstable. By unstable, what I mean is it can't exist. It can't live on its own. But not all atoms. There are some atoms. Let me tell you the exceptions also here only. Remember inert gases? They are, my God, stable, and they are very stable, and nothing can disturb them easily. Okay? That way there are some more atoms which are stable. And because atoms are generally unstable, they want to acquire stability and they go combine with other atoms. How? With the help of attractive forces. If this is an atom, because this atom is unstable, it will hold the hands of the other atom. Not exactly hands, but then each atom would be holding other atom with the help of some sort of chemical force of attractions. We call them as chemical bond. You studied about ionic bond. How many of you remember ionic bond? Yeah, ionic bond in metals and non-metals, right? Which is formed due to attractive forces between cation and anion. Yes, same way, two atoms also can attract each other in order to form a chemical bond. It is just like holding each other. Now, if you are very unstable and you're feeling giddiness and you're about to fall, your head is spinning and you're about to fall, and what do you do immediately? You look for a support, right? You look out for a support. Yeah, you hold hands of the people who are right next to you, correct? And otherwise you try taking support of the walls or whatever. Yeah, same is the case with atoms also. Atoms cannot exist. They immediately keep on reacting, and in order to sustain that, in order to keep them stable, they always take the help of their other atoms. By forming a chemical bond, they attain stability. Yeah, and once they form chemical bond, now see, you have atom 1, atom 2. They have formed a chemical bond, correct? And atom 1 and atom 2, after forming a chemical bond, they are no more called as atoms, because it's not one atom now. They are a collective stuff now. They are combined with each other. They are together, right? And then we call it as molecule. What do we call it as? We call it as a molecule. And guys, those who had a confusion between atom and molecule, note it down. Atom is the basic unit of matter which is pretty unstable and it cannot independently exist. And in order to stabilize itself, it will combine with other atoms with the help of chemical bonds, lead to formation of molecules. And molecules are very stable, very stable, right? Yeah, are we clear? Clear now? Well, so atoms are very finer. They combine with other atoms to form molecules. But then you know what? When I say they combine with other atoms, one question comes. Do they combine with similar type of atoms or do they combine with dissimilar type of atoms? Right? Both are possible, isn't it? When you're falling off, you may hold the hands of other human being or you may take support of the non-living stuff like furniture, walls or whatever. Yeah, it's possible, pretty possible. Correct? Here also same thing. Atoms unite with each other as a result of which they form molecules. But then with which type of atoms are they uniting? Are they uniting with similar type of atoms or dissimilar? Both are possible. In case if they are uniting with similar type of atoms, we call them as homoatomic molecules. Remember the first poll question of today's class? Homoatomic molecules, right? Homoatomic molecules. What is homoatomic? Try to split this word. Homo means similar, atomic means atom containing molecules, right? So if a molecule is formed out of combination of similar type of atoms, we call it as homoatomic. Yeah? And the other way around. If a molecule is being formed due to combination of dissimilar type of atoms, not similar, like some different types of atoms, we call it as heteroatomic. What do we call it as? Heteroatomic molecule. What is hetero? Dissimilar. Atomic, atom containing molecule. Yeah. So when you have similar, you call the molecule formed as homoatomic molecule, and when it is dissimilar, we call it as heteroatomic molecule. Hold on, let me give you some examples so that you understand it better. Okay, so similar type of molecules or similar type of atom containing molecules like CH2, hydrogen and hydrogen, two hydrogens, right? Yeah, so it is homoatomic, isn't it? Now, very good. Rahi says O2, homoatomic. Some more examples? Some more examples? Yeah? Very good. Hiba says H2O, heteroatomic. Good. Fe2. Let me tell you guys, this homoatomic heteroatomic system is not applicable to inert gases, and for metals, certainly not applicable, because someone said, who said, Adrita said Fe2. In fact, it is not exactly Fe2. It is Fe. The number here is big. All the metals have a big atomic number, which is very hard for us to tell, because metals exist as clusters. So we don't write atomic number, also we don't write atomicity of metals easily, right? So we can't write it as Fe2 because it's not exactly Fe2. It is some huge number which we don't study in books. Yeah, right? But then Fe, iron, is homoatomic for sure, right? Any other example? F2, Sahil says F2. Very good. Then N2, very good. Who is this? Rahi again. Rahi again. Yashika, do you mean sodium or not applicable? Yeah. Advita, Cl2, good, good. Guys, from this it's clear that you have understood the concept. I'm glad for it. And S8, who said Zubin? P4, who said me? O3, who said again me? These all are examples of homoatomic species. Homoatomic molecules are the ones which contain similar type of atoms, and note it down, there is another name for homoatomic molecules. Homoatomic molecules can also be called as elements. Yeah, homoatomic is like, you don't find this term everywhere, but then we commonly call them as elements. Okay, so right, elements are homoatomic by nature. They have similar type of atoms, and what? They are stable because they are molecules, right? Now let's go to the other stuff, that is heteroatomic, which is also called as, any idea? Other name for heteroatomic is? Other name for heteroatomic molecules? Very good. Swati and Ismail answered correct. And others also have done. Those are the first ones to answer. They are also called as, what am I doing? I'm writing again as heteroatomic. Yeah. They're also called as compounds. Okay, H2O is one example. Some other examples, please. HCl, Rahi, good. Next. Very good. CO2. Next. SO3. Very good. NaOH. Perfect. You guys are rocking. That means you have understood what is the difference between element and compound. Good. So this is about elements and compounds. Coming back, matter is made up of finer particles called as atoms. Atoms are very unstable. They can't exist independently, and as a result of which they combine with other atoms, maybe similar or dissimilar, to form a stable system called as molecule. And based on the composition, if the molecule is consisting of similar type of atoms, you call it as homoatomic or element. Examples on the screen. And if the molecule is consisting of dissimilar type of atoms, we call it as heteroatomic, or we also call it as compound. Examples again on the screen, right? Are we clear about the difference between atom and molecule? Those who had a doubt about it, are we clear about it? Yeah, right? Yes. So now I see some of you asking me doubts. Please do give me one more moment of time so that I can have a doubt session with all of you. Okay. So let's come back to the flow chart, and we were talking about pure substances. Yes. Pure substances are the ones which have similar types of molecules. Now do you remember what molecules are? Similar type of molecules are the ones which have some cluster of atoms with them. Atoms are different and molecules are different. Molecule is a stable unit, and that's a combination of different atoms, or it's a combination of some number of atoms, similar or dissimilar, correct? And if you have similar molecules, that's when you call some sample as pure. Okay, and if you have dissimilar molecules, you call it as impure. Are we clear now? So pure substances are the ones which contain similar types of molecules, right? And how many types of molecules do we have? We have two types of molecules. One is element, other one is compound. Are we clear? Is there anyone who has a doubt? Why is compound pure substance? Is there anyone who is still worried? Why is compound pure substance? Like H2O, why is it pure substance? HCl, why is it pure substance? Dear students, because H2O and HCl, see, they have one type of molecule only, H2O. All together is one molecule. Let's not talk about atoms, because purity is based on the molecules, right? So compounds and elements both are pure substances, right? Are we clear so far? And now, going one step ahead of the classification, elements are again classified. Again classified based on their chemical properties into three types. Anyone in the class who can tell me all the three types together? Very good. Zubin is the first one to respond, and then let me see who is the second one. No response to that. Still, Zubin is the one and only student who have answered. Very good. I know you have taken some time to type in. Agrita, good. Rahi, very good. Top 3 students. That's good, guys. Elements are further classified into metals, non-metals, and metalloids. You know what? This is also not new for us. Remember class 8 CBSE? Metals and non-metals. Remember physical properties, chemical properties, uses, alloys. Yeah? Same thing. So this is the entire chemical classification of matter. Chemically, matter can be classified into two types. One is pure, second one is impure. Impure, homogeneous, heterogeneous, solutions, colloids, and suspensions. We're not talking about it at all in class 10 CBSE. Forget about it for now. Coming to pure substances. Two types of pure substances. One is element and another one is compound. Compound, it's only one type. Let it be aside. Elements are further classified into three types. Based on what? Based on their chemical properties. How do they react with other atoms? Okay. Elements are further classified into three types: metals, non-metals, and metalloids. And we know what metals are, what metalloids are, what non-metals are. Do we know it? Yeah. Class 8 though, okay. Did you study it in class 10 also by chance? We did last chapter around 7 classes we spoke about metals and non-metals. 10.5 hours we spoke about it, isn't it? Yeah. And you're soon going to have a unit test also in this, right? Yes? That's a good memory. Last class also was metals and non-metals, right? Yeah, I was waiting. If somebody says no, then okay, anyways, metals, non-metals, and metalloids. This flowchart is very important. This and the second flowchart, make a note of it and keep. This will help you anywhere in chemistry, not only class 10 boards. If you're preparing for NTSC or any other Olympiads, and if you are in class 11, even then you need this clarity. Okay, so now we still have not started with any chapter. Do you know that? We are working on the basics. We are just working on the basics of chemistry. Since we are one step ahead in the syllabus, we have a little free time. We can afford spending some time today for the basics. Okay, I'm focusing on your basics right now because when I saw a few of your papers, unit test papers, and when I observed the type of questions that a few of you do ask, I clearly see that you have some gap in the basics of chemistry. Okay, so you have some other gap to be filled around this basic. You can ask me. You can right now ask me for your doubts. I'm waiting for your doubts now. Yeah. Right. When is the unit test? Soon. And I mean, guys, do you know the date of your unit test? I'll check and tell you. You want me to check? And waiting for your doubts. Aha, what is antimatter? Such a lovely question. But I can just give you a brief idea about antimatter right now. You know why? It is something which is out of syllabus. It's not the basics. It's like beyond the basics. Yeah. Antimatter, first of all, we don't have antimatter on Earth. Okay. And the second thing is, antimatter is understood according to two theories. So far, there are two theories which talk about or which discuss about antimatter, of which one theory is based on gravitation. Another theory is based upon the chemistry, as in the subatomic particles, protons or neutrons, or which other subatomic particles does it have. Okay, so according to gravity, they say that antimatter is something which has opposite gravitational action of matter. For example, if matter is attracted towards gravity, antimatter is something which is repelled by gravity. This is according to one theory. And according to second theory, that composition by subatomic particles, matter and antimatter are supposed to have similar composition. They have similar protons in the nucleus and they have similar subatomic particles. And because they both have similar charges or similar composition, antimatter and matter repel each other according to the concept of composition. So right now we have a synthetic antimatter, but then we cannot expose it to the open atmosphere because it is not yet stable. So once it gets stable, the scientists have to expose it to the open atmosphere, and that's when we'll get to know if the theory of gravity is correct or the theory of matter antimatter is correct. So, and coming to the unit test, you have your unit test, I guess, on 20th September. Unit test free chemistry 20th September. Yeah, right? Next question. Swati, can we? Yes, why metals are partly not applicable for this classification? Definitely, I know what you are trying to ask me. I said metals cannot be written as Fe2, Na2, or Fe3. That's because what is that 2 and 3? When we write Fe2 or when we write say O2, what does it mean? Let me just write it down on the white page. Yeah. What does it mean if I write O2? That means oxygen has 2 atoms per 1 molecule. It's atomicity, right? We learned in balancing equations. Yeah. But then for metals like iron, copper, zinc, it's not 2 atoms per 1 molecule. Then how many atoms? 5, 6, 7, 8, 10? No. The number of atoms per 1 molecule of metals vary. Sometimes it is 10, sometimes 50, sometimes it is 100. They vary extensively because all the metals exist as groups. They exist as clusters. And it is difficult for us to count the number of atoms per each molecule, because they're never specific in the count, right? So what do? Is we write metals as their symbols only. We write it as Na, Fe, Zn. You might have seen symbols of metals this way. Have you ever seen Zn2 or Fe3? All along, have you ever seen this way? You wouldn't ever have, because we can't specify the number of atoms of metals because they vary. Sometimes they are 10, sometimes they are 1,000. So we don't write atomicity for metals, only metals. Okay. Swati, please do confirm if your doubt is clear. Next, can we define molecule as group of atoms? Yes, Pavitra, group of atoms attracted towards each other with the help of chemical bonds. Existing of chemical bonds is mandatory when you call a group as an atom, as a molecule. Okay. Next. No, Ismail, I don't teach in any other school. I teach only for Vedantu. Like my whole day, I have classes for Vedantu. And other than classes, I take free webinars and I take live streaming on YouTube. So it's all contributed to Vedantu. And other than that, I research. I hope you know, right? I have a doctorate in chemistry. I research on the drugs and medicines which are related to cancer medication. Okay. Well, and if you want to know the medicine name that I'm working on, this is it, Triapil. This is one medicine which can act against the tumor cells. But what am I doing now is I'm trying to synthesize the derivatives of this medicine. You know, the metal complexes of trypin, which will be helpful to treat the tumor cells even at advanced stages. Right now, for advanced stage tumors, we don't have proper medication, right? Even chemotherapy doesn't stand effective for last stage cancers. So I work on the medicines. I work on a research with the help of which we can try synthesizing some medicines at stage 4 of cancer. Coming back, so I research and I teach at Vedantu, nothing else. Well. Next, any example? I think, Yashika, you're talking about examples of metals and I have written it. If you're talking about some other examples, please do let me know. Yeah, compounds are dissimilar, then how is it pure? I knew this. I knew a few of you would have doubt about it. So let me explain this point a little in detail again, okay? Because you know what happens? Because of this confusion, you will end up losing marks sometimes in your school test. Not at board level and all, but then yes, in your school test. So some of you is asking, I don't want to reveal the names, but some of you are asking that when a compound, I'm talking about this, when a compound is having dissimilar type of atoms, how is it said to be pure? You know, how can we say it as pure? I repeat the definition of purity. I have to say something to be pure when I have similar type of molecules, not atoms. Forget about atoms. Yeah? When you have similar type of molecules, you call the substance to be pure. Now, if you're worried about H2O, say I have a tank filled with water molecules, only H2O altogether. Okay? And now in this tank, my question is if it is pure or not. To justify this to be pure or not, simple thing we can do is check if it has all similar type of molecules. I repeat, similar type of molecules. Okay? So H2O. First molecule, H2O, second molecule, third molecule, fourth molecule. See all the number of molecules, they all are H2O. Other than H2O, do you see something else? No, right? It's only H2O. It has only one type of molecules, similar molecules. And if you have a sample with similar molecules, you call it as pure. And now inside the molecule, if you have dissimilar atoms, that's okay. You refer it as compound, that's okay. Purity is at molecular level, not at atomic level. I hope this point is clear. If not, please do let me know. Half-yearly exams in September. All the best, Ankit. Prepare well, and any help in chemistry prep, reach me out. Yeah, and you need any other material, important questions, shortcuts, you can ask me for it. If I have, I'll definitely provide it. Yeah. Example of antimatter. Antimatter it itself is one. There are not many types of antimatter. It's only one, just one, right? No more examples. Examples are when we have multiple versions of something, right? So antimatter is only one version. It's only one. Okay. Next. What is meant by 22 karat gold in terms of percentage? 22 karat gold is nothing but I'll tell you, see, it is 22 parts of gold and 2 parts of silver or copper. Maximum is 24 parts. Out of 24, 22 karat means 22 parts of gold and 2 parts of other copper or silver. 18 karat gold means 18 parts of gold and rest 6 parts some other impurity, could be copper or silver, right? Anyone seeing multiple screens? Anyone starting multiple screens? No, right? If so, please do let me know. Right. That's pretty good. No, 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 no. Some of you are seeing multiple screens. Some of you are seeing multiple screens. Guys, please do refresh. You shouldn't see multiple screen. I'm using only one screen and one video. So you should see only one and one. If in case you see more than that, please do refresh the page. And Zayed needs important questions of metals and non-metals, because definitely Zayed, did you ping me today? Somebody else also asked me. Okay, not you, Neil, another student of some other batch also asked me. Zayed, please do ping me personally. I'll share the stuff with you. Okay? Yeah? Right? Well, guys, see how many questions you are asking out of the topic. You know, it really excites me when you ask me this kind of questions. It shows you are very interested. But why don't you ask anything in the group? Why are you so quiet in the group? Yes, we can count metals in homoatomic. They are homoatomic. Only problem with them is number of atoms per molecule is not constant. Yeah? Right. So guys, I still have some of your doubts which are not related to the syllabus, not related to the current topic, but then yes, they are important. Can we please talk about it in the WhatsApp group? Can we? Yeah? Right? I'll do something. Okay. Please do talk about it in the WhatsApp group. Right? Yes? See, radioactive metals. Metals, all metals are homoatomic. Let it be radioactive or non-radioactive. Yeah? So guys, now coming back, we actually have to start carbon and its compounds according to the flow of our syllabus, but then let us first start periodic classification of elements and then go to carbon and its compounds. The reason behind this is periodic classification of elements needs a little more time for you to learn and work on it. So rather than placing it at the end, let's finish it off now, so that by the time we complete carbon and its compounds, you can parallelly keep revising periodic classification. And by the time when we end carbon and its compounds, we'll be perfect with both the chapters. Okay. So today, though the chapter number 4 is carbon and its compounds, we're not starting with it. We are starting with periodic classification of elements. Okay. Yeah. So shall we start with the chapter now? Shall we? Yes, that's very good. Guys, do not get disheartened because I did not take a few doubts from your end, though I have seen them, but I did not take a few doubts just because of one reason, that they'll take a lot of time right now. And I guess it would be great if we can talk about it in the WhatsApp, because in WhatsApp, I'll give you the notes, right? You can keep it for your further reference also. Okay, so I hope you guys understand, and do reach me out in WhatsApp soon after the class is also fine with me. Okay. Yeah, so shall we start with the class now? Shall we start with the chapter now? Shall we? That's good. Well, as I told you, this flow chart, everything is not a direct part of this chapter, but then indirectly, yes, it's a part of our chapter itself. Okay, so in this periodic classification of elements, we talk about all the elements. Do you see this? We talk about all homoatomic molecules, which are also called as elements, right? So coming back to the bigger flowchart, we are talking about elements. How many types of elements do we have? We have metals, we have non-metals and metalloids, right? 3 types of elements. We talk about all these 3 types of elements, not their properties, but then about their arrangement. How exactly these all elements are arranged and why should we arrange? No. You might be thinking here about arrangement of elements. Why should we study one big chapter? Is it not pretty easy? Yeah, but actually not. because the arrangement of these elements has to happen in a very systematic way, and there should be proper logics behind it. And keeping all this stuff in notice, arranging these elements is not an easy task, and it's a tough task. And if you are not surprised, let me tell you something. Arrangement of elements has been happening from past 120 years and more than that. I can say from the middle of 18th century it has been happening. But many flawed theories, many updations and all that. So all over from 100 to 130 years, this arrangement, the work, research on the arrangement of elements is happening. Do you believe this? So arrangement of elements is that tough. So we are going to talk about arrangement of elements in the periodic table today. Okay? Yes. So now before we could talk about it, let me just check with all of you if you are understanding what is happening in the class. Are you understanding? Yeah? There was some sort of disturbance, so please do ignore it. Maybe somebody has got themselves unmuted. Yeah, ignore that. Yes. So are you able to understand? So far we have spoken about matter, its classification, what are compounds, what are elements. So now in this periodic classification of elements, we're talking about elements, not about compounds at all. You're not confusing yourselves with elements and compounds still, right? We don't talk about compounds. We don't talk about H2O, CaOH twice, NaOH and all that. We talk about elements. We talk about different types of elements. How are they arranged and all that. Okay. So in this chapter, let me first tell you the content. Let me just give you the, content line. Okay. In this chapter, what all do we talk about? First thing, we'll understand what elements are, which we already have done. Did we do it? From beginning of today's class, this is the only one thing that we have done, right? Understanding elements. What are elements? Okay? And after that, we divide the chapter into two parts. Part 1 is history of periodic classification. Don't think that since it is history, it is everything that happened before today. No, it's not. History of this periodic classification is everything that had happened till 1930. 1930. Okay? Yeah? And the second segment of this chapter is the modern periodic table. Modern periodic table. And I'm sure no one in the class are completely unaware of periodic table. Are you hearing the term periodic table for the first time? Don't tell me. Are you listening to the word periodic table for the first time? No, right? You might not be knowing how arrangement and all happens inside it, but then we know as a chemistry student, we know what periodic table is. Why all that? We have seen periodic table of metals and non-metals during classification, correct? So periodic table, modern periodic table is the second part of the chapter. And after we study modern periodic table, we also study about a few more concepts which I'm listing as a part of it because they are also related to modern periodic table only. In this, we talk about arrangement of elements. Okay. After arrangement, we talk about periodic trends. And let me first of all tell you, periodic trends is the most important subtopic of this chapter. Most important subtopic. Okay, right? So the chapter is divided into two parts. Part 1 is history of periodic classification, whichever happened before 1913, and the second part is modern periodic table from 1913 to till now. It's only one periodic table being maintained from this century. That's why it's before 1913 and after 1913. Okay, yeah. So after 1913 till today, only one periodic table we have. That is modern periodic table. That's what we study in the second segment. This is the content line of this chapter. And now I have somebody asking me, what does periodic means? I'll tell you, don't worry. It's very simple and I'm going to tell you step by step. And other than that, are we doing chapter number 4 and its compounds? We are doing chapter number 5. See, that means you're not listening to me completely. Did I not tell you we are doing chapter number 5, periodic classification. Why are we doing this, guys? Because this chapter is a simpler chapter. Is it? Is that because of that? No. Periodic classification of elements is a little confusing and it needs a lot of work to be done. So if we finish up with this first, we'll get enough time to understand this chapter and complete this chapter. After this, we are going to complete carbon and its compounds, which is not very difficult, which is full of theory. Okay? Yeah? Right. So now, periodic classification of elements is happening. The order is slightly changed. We are completing chapter number 5 first and then we are going to chapter number 4. Now I'm sure by now everyone's clear. Okay. So now my first question for all of you is, in the periodic table, what we are talking about? Are we talking about elements or are we talking about compounds? I want to see everyone answering. In periodic table, what are we talking about? Are we talking about elements or compounds? We're talking about elements. That's good. How many elements do you have? According to you, how many elements are there in the universe? Now, by now, 2018. How many elements? We have 100 elements. Is that? Very good. It's not 108. It is not 114. Who is this? Ankit, 1000 elements. I'll tell you something, wait. We have 118 elements. 118. Okay? 118 elements by now, 2018. After all updations. For this 118 elements study, in class 10, you have only one chapter because we are at the learning stage. In class 11 and 12 altogether, you have 6 chapters. 6. Okay? Assume you have 1000 elements in the periodic table and from there you try to understand how many classes, how many chapters would you be needing for it. Yeah? So, it's only 118 elements. Okay? So, we have 118 elements in the periodic table and we are talking about classification of those elements. Okay, are we clear? We are talking about what? We are talking about classification of those elements. But then why is this term periodic classification? Somebody asked me, Devendra asked me, why? What is periodic? I'll tell you what is periodic. Before that, answer one of my questions. Every morning you wake up certainly at some time in your school days, not on your holidays. You wake up certainly at around 7 or something. And you go to school at 9, yeah, and you have your lunch around 1. You come back from school maybe at 4. Next day again at 9 you go to school. You come back at 4, isn't it? So regularly you keep doing this stuff, yeah? Yes. So this regular trend is nothing but periodic. Periodic is when you have regular trend happening at specific intervals of time. Like see, commonly in India, climatic conditions are, seasons are like this. Every January is a winter, right? And every May is a summer, almost. And every August is rainy, more or less, but then yes, is it not? The seasons are pretty standard. And next year, again January is a winter, May is a summer, August is a rainy. Correct? So this way, if something is happening repeatedly at regular intervals of time, we call it as periodic. Why all that? In school, the classes, you refer them as sessions or periods, isn't it? Yeah? First period, second period, third period, right? Why? Because every period is a repeated process. It happens for around 45 minutes or 40 minutes, depends upon your school. And after every 40 minutes, it's a repeated new session starts, new class starts, right? Period is something which happens repeatedly at regular interval of time. Underline this term. It happens at regular interval of time. Okay. So periodic classification of elements. It means that we are classifying elements according to their regular behavior. I'm not classifying them randomly as I want, right? We are classifying them based on their regular behavior. Regular behavior. Let it be a physical, chemical, that is secondary. But then regularly, a few elements exhibit certain behaviors, and based on their regular behaviors, their regular trends, we arrange the elements of elements of the periodic table in proper systematic standard way. That's why periodic classification of elements. And about the term periodic, We're going to talk extensively in the class. Okay, so our chapter today is what? Periodic classification of elements. And elements are homoatomic by nature, and elements are 118 by number for now. Okay, so as you know, there are two parts in this chapter. Part number one is history of periodic table or history of periodic classification. Part number two is modern periodic table. In modern periodic table, we study about periodic trends, classification, everything and all that. But then right now, let us start off with history. Okay. So before we could start off with history, let me tell you something. Now we have 118 elements. Okay. Now we have 118 elements, but then before 100 years, that means 2018, 1918. Do you think we had 118 elements then? Do you think we had 118 elements? Okay, no. If not, how many elements would have been there? How many elements? Any idea? Any idea? Number of elements? No? Very good. Less. Definitely less. That's true. 100, not even 100. 116. No, no, no. Who is the smart person? Shreyas. Good. 52 once upon a time. Okay, but it's very close to the right answer. Under 50, Yashika. Good guess. Harshit, 50. Good guess. 52 Shreyas again. Good, good, good guys. Very good guess. Those who have guessed around 50, yes, you are right. You know, before 100 years. Why before 100 years? Let me tell you from past. Before 100 years, as in not only in the year 1918, below 1918, we had really less number of elements. For example, if you have taken 18th century, we were having elements which are close by 30, 30. The number is not exactly 30, it was 33. Okay, so before 19th century, that means in the last stages of 18th century, we were having around 30 elements, 30. Imagine how easy would it be to study just 13 elements, right? Later, as the time passed, around beginning of 19th century or ending of 18th century, the number of elements increased to 56. Okay, and slowly studies were happening simultaneously and the number of elements increased to 63. The reason I'm talking about these specific numbers is there is one theory of classification proposed at every point, and according to those classification theories only I'm giving you the numbers. Okay, so at some time there was 63 elements, but then as the time passed the number of elements increased drastically, and as a result of this we have to rearrange the elements again, and the number of elements was 113 in the last 50 years, then it became 114, and now we do have 118 elements. So if you observe, the number of elements was increasing right from 30s to 118 till now, right? So number of elements was never standard and it was never a gradually increasing count, right? So it was not like, okay, today 30, tomorrow 31, day after 32, then 33. It was never a gradual increase. It was just all of a sudden increase because it was not one scientist who was working on it, right? There were multiple scientists who were working on this number of elements, discovery of elements. So we had the drastic increase in the number of elements as the time passed. And because of this drastic increase, what happened? There was necessity to arrange the elements again and again and again and again, right? So now guys, let me tell you, since the elements are classified into metals, non-metals and metalloids, in fact, let me ask you, how many years do you think human is using metals from? You're studying social science also, right? The history, geography and all that. So any idea from how many years we are using metals? Human beings are using metals, not you and me, but yeah, human beings, our ancestors, since, okay, since the starting millions of years. Okay, but then what exactly? Bronze Age, more than 1,000 years. You know, 1,000 years, like it's Very less for the history of a metal. Very less. 1,000 years as in now 2018, that means 1018, right? You remember the history of India. I'm just giving you the bigger points, the names of the bigger emperors. Mughals, they used metals, right? Have you seen Jodha Akbar movie, which describes the Mughal Empire and the culture of them? Correct? They used jewels, right, in that movie. That means what? Metals were there. Metals were there. Jodha Akbar ka time. Jodha Akbar ka time is what? Mughals ruled India before 15th century, from 11th century to 15th century, roughly. Yeah. So it's there. Then any other idea? How many years? Someone said Bronze Age. That was a very good guess. Other than that, good, good, good. Since before Christ, Stone Age. Okay, that's good. Which metal do you think is the oldest? The oldest metal. The oldest metal of the world. Oldest metal as in according to discovery. Maybe metals were existing from the time of Earth's existence, but we weren't there. According to our discovery, which is the oldest metal? Gold, silver, platinum, iron. Okay, that's a good guess. Bronze, I knew this. I knew you would say bronze, but then let me tell you, bronze is not a metal. It's a mixture of metals. It has copper and zinc. It's an alloy, right? So bronze can't be counted. Next, copper. Very good, very good. Well, guys, so let me just show you one flow chart, okay? So it's not a flow chart, it's an infographic collected from some source, but it will give you a lot of insights on existence and discovery of elements. Do you see the screen now? Please do confirm. Do you see screen with some infographic metals? Yeah. This is like, the time era of metals. Take a look at this. In 6000 BC, gold was used. Before that also, we were having some metals which were used in form of mixtures in the Mesolithic era, but then we're not counting it because it's not too specific if it is a particular metal. If it is gold or platinum, it isn't specific. It's a mixture of metals. So we are starting off from 6000 BC. Gold was in use. Okay, and after that 4000 BC, silver, another old metal. Copper, you know, right, how important copper is in the civilization of human culture, right? It's very important, correct? Then after copper is lead. Lead 3500 BC. These all are metals, right? Yeah, which are nothing but elements. See, iron, human used in 1500 BC. 1750, tin. There are some images also. Do you see this? Yeah. And mercury. Mercury here is represented as stone because in nature mercury is obtained in form of ore. Remember, metals and non-metals extraction. Mercury is taken out in form of mercuric oxide or mercury chloride. Yeah. So here is a stone of mercury. Right. Next, metals discovered in the 18th century. So this is all the time span, but then in 18th century, that means very recently. Take a look at these metals. Do you see? 1753, bismuth, and then manganese, and then 1775 was the American Revolution, and then molybdenum, tellurium. Tellurium is one of the radioactive metal. And later, take a look. Nickel, zirconium, tungsten, we used in the light. Yeah. I hope you all know the names of these metals. And then is uranium. Uranium have now changed the power supply trend. Once upon a time, we needed carbon like something. We were too desperate about carbon because that was the one and only support for us to produce electricity. Now, uranium is there. Uranium is very effective in power supply, in production of electricity. I hope you all know uranium, nuclear power plants. By now, by 2018 June, India has 28 nuclear power stations. A few of them under construction, few of them under operation. Okay, so 28, which is pretty high number. Yeah, and Japan is also using nuclear power reactors to greater extent. I hope you remember before 6 years, I guess, Japan had an earthquake where nuclear reactors were destroyed and radioactive metals were exposed. due to radiations. Many of them were injured. How many of you know this news? It happened before, it happened in 2011, I guess. Yeah, that was a very dangerous situation, correct? That was because of uranium. Uranium is used in the reactors. Well, after uranium, titanium, not of big use to the domestic life, but then industrially used. And then yttrium, beryllium, many more, chromium. I'm just focusing on the elements which we are very aware of, which are very essential. Silicon, 1823, silicon. Do you know how useful silicon is? Yeah, I'm sure you must be knowing, like, we are using technology, right? How does all those laptop system, everything run? How does it all run? With the help of silicon, right? Silicon Valley of India is what? Silicon Valley of India is, I'm expecting right answers at least from those who are living in Bangalore. Very good, it's Bangalore. Because IT industry is well established here, and all the IT industry, every system, every PC needs silicon chips. So silicon is discovered in 1823. Aluminium, one of the most abundant elements in the earth crust, cheaply available, and it is less corrosive comparatively, used in manufacturing of utensils, tanks, reaction vessels, whatnot. And after aluminium, I'll show you some other important metals. Okay, so some other important metals are, okay. Do you see germanium here? It is used in semiconductors, which are in turn used in IT, in turn used in the, what to say, systems. Yeah, right? And then polonium and radium. How many of you have studied about Madame Curie? Madame Curie is the actual pronunciation, but you can call it however you want. Madame Curie, the person who researched about the radioactivity and discovered what? Radium, 1998. And she died unfortunately due to radioactivity only, due to penetration of radioactive radiations. Yeah, many scientists, they have died because of their work only. Yeah, have you heard of Srinivas Ramanujan, the mathematician? Wonderful mathematicians, India based. Remember, he died at the age of 32 years because of some neurological imbalance, because he was extremely genius, and if he was alive, he would do wonders in mathematics. The same way in chemistry also, we have one scientist by name Henry Moseley. How many of you have heard about this name before? Henry Moseley? No? You are going to study about him. The modern periodic table is framed by Henry Moseley, a scientist. Yes, he's not India based, don't worry, but then he was very genius, but he also died at very young age, around I guess 28 or something. I'm not sure about the age, but then he died at very young age because of World War. Yeah, so he was affected by the explosions of World War and he died. Well, anyways, coming back. Metals discovered in 20th century. So it's very close to our age group, right? Well, Europium, World War I. Next, hafnium. I'll show you something which is very important for us, francium. Francium is radioactive. Yeah. And then 1969, look what happened. There are some instances also related to it. So instances and of course the metals. Yeah, right? Very good. So guys, this is the history of elements. And the reason I have shown you this is, you have seen this, right? Is there a gradual increase in number? It's not, right? If you observe 19th century, look at the total number of elements. It's high, right? 18th century again is high. But then before that, number of elements discovered was like very less. Yeah, before 18th century, take a look. In 17th century, there were few elements. But before that, there are very few elements, right? So as the time passed, the number of elements went on increasing. So we could never stick to one fixed arrangement, because this arrangement is not happening randomly. It's happening based on the physical and chemical properties of all the elements, right? So before going ahead, let me just quickly ask you a question. Is there anyone who has a question? Though we have not discussed a lot about the chapter, but then yeah, we have discussed a lot of points which are helpful for your knowledge with respect to competence, NTSC or whatever. Yeah. So here is someone who have sent me the information about Henry Moseley, an English physicist whose contribution to the science and physics was justification. It clearly seen that it's a copy paste. And someone who is asking me about the spelling of the scientist Henry Moseley. Yes, I'm just posting the spelling right here. Okay, I hope this should help. It's in the chat box here. Next, the present periodic table is based on Henry Moseley. Yes, who is this? Shreyas? Good. Well, great people do not live long. That's true, Adrita. Well, spelling of Henry Moseley is being done, is being given in the chat box. I hope all the doubts that you have asked are covered. If you have anything else to ask me about it, you can please ask me. Yashika, such a beautiful question, radioactive, and I would love to explain it in the WhatsApp group. You know, the reason I take a few questions, especially in the WhatsApp group, I want to tell a lot about it. Yeah. So can we please do it in the WhatsApp group? CuCl2 question. You know, the CuCl2 is in my mind because you posted it before some time also, right? Yeah. This also WhatsApp. 2 questions for WhatsApp. Yashika's and Harshit's. Done. Harshit, I want your confirmation as well. And radioactivity, yes, that is Yashika's question. Any other question, guys? Any other question related to this? For atomic number, known for atomic number and Moseley's law. You're talking about the scientist. Empirical formula, Harshita. Somebody else also asked me about empirical formula. Devender, you right? Harshita, is your doubt about empirical formula has not been explained or something? Yeah? Right? It's not done. Can you please remind me? Can you please remind me one more time after this class, soon after this class? Yeah? Right. And guys, rest of you, if you are listening to the term empirical formula for the first time from my mouth, don't worry about it. It is something which you're going to learn after your 10th standard. But then for those who are preparing for any of the competitives like MDSC or SECO or whatever, it's needed. Okay? Yeah, Newlands, etc., etc. Very good. Shreyas, it clearly shows that you already have done with the chapter. Have you? Well, anyways, coming back, guys. Coming back to the chapter, we're talking about periodic classification of elements. We're talking about periodic classification. But then, why should we classify elements? Why should we classify elements? Why? Why can't we have the elements randomly? Is there any use out of classifying these elements? Easier to study easily, to know the properties, to make study easier. Okay, that's good. You're on the right track. Take a look at this image. What is this? So many books in one place. Obviously, it has to be library. What is this? Somebody asked. Okay, Yashika says this is a mess. And Shreyas says this is life. Well, any other interesting answers? Harshita also says it's mess. Dirty library, Pavitra says. Well, guys, well, this is my room, Rahi says. Rahi's room is filled with so many books and all the books are in mess. She says. Harshit says this is hell. This is Einstein's room, Prasanna says. Okay, not Zayed's room. This means Zayed, you are a neat person. Keep it up. Ismail says this is a paradise, and guys, let Ismail live in this paradise. Yeah. Storeroom. Who is this? Yeah, Rohan says storeroom. Bedroom for sure we can play. Garbage. My mother would go crazy if this was my room. Tarini says. Very good, guys. Very good. That was interesting set of responses. I did not expect this. Anyways, coming back, this all are books, right? Yeah. But then the messed up books, as you already have said, they all are messed up. And now from this mess or from this unevenly distributed books, if I ask you to pick class 10 CBSE science textbook, how many of you would do it in 5 seconds of time? Can you? Class 10 CBSE science book. How long does it take? It would take little long time or just like this as a magic? Have you seen the movie Robot, Rajnikant? Yeah? Have you watched it? It's about a robot, right? Where the hero would be constructing a robot which has immensely high artificial intelligence, right? Yeah, unless and until you are that robot, you will not be able to sort out these books in seconds of time, right? Yeah, Dr. Vasikar. Yes, Devender, Dr. Vasikar. Coming back. Now, in order to identify the stuff easily, in order to pick whatever we want easily, what if we organize this book stuff in this manner? How does it look like? Is it better than before? You see the image now, right? It's been arranged in the shelves, particularly. Now it gets easier for us to go through the label of every book and find out what we need, right? Yeah. So now comparatively, the rearranged form of the books gives us more convenience to find what we want and to acquire what we want, right? And we also can get to know, like if we have science books, maths books, or what sort of books do we have, right? Yeah. Now I'll show you some other image. Okay. Take a look at this. This is also rearranged form of library, but here you have books arranged according to the subject. The labels are not clear, but then yeah, they are according to the subject. Maybe science, maths, electronics, whatever. And now if I ask you, go pick a book of electronics and come. Does it take lesser time for you than previous cases? Yeah, it's a school library, that's true. It's a picture of school library. It's pretty easy now, right? Because we have arranged in the previous case and this case, we have arranged according to our ideology. We know which subject books are present in the first shelf, in the second shelf, and in the third shelf, right? So compare all the three cases. When it's a mess, it gets harder for us to find the books, to know which books do we have. Second case, when we have all of them arranged, it's comparatively better. But in third case, when we arrange them systematically according to some ideology, some strategy, it gets easier for us to identify and pick the book. And moreover, now we can also easily say electronics, there are 10 books, chemistry, there are 15 books. We know the number. We also can have a comparative analysis, right? Yeah, comparing two different domains here is very easy. This is the power of classification. This is the power of arranging stuff in a systematic way. Elements also same. Now we have 118 elements. And if these all elements are scattered, according to me, first element is neon. According to you, first element is hydrogen. And now we are in a discussion. I say first element is inert. You say first element is reactive. Both are correct. But then a lot of confusion. If this is the case with you and me, what is the population of world? Imagine the confusion that would arise over there, right? So it's very confusing, and moreover, we will not have a clear-cut idea. Science is universal, and in science, everything should be standardized. You take names in botany or in biology. Did you study the scientific names of plants and animals? Yeah. What is Azadirachta indica? Azadirachta indica is scientific name of? Are not mango. It is neem. Who is this? Devender. Good. Keep it up. Mangifera indica is mango, right? So this way we have scientific names for everything. NASA is the scientific name of? It is a scientific name of NASA. Yashika, I'm going to kill you. Harshita, I'm going to kill you again. It is the snake. It is a cobra. Indian cobra is called as NASA. Yeah? Not Homo sapiens. Okay. Sorry, Homo sapiens, you're talking about something else, right? So, yes. We are going to standardize and universalize every name that we talk about. Every name that we talk about in science. The same way, arrangement of elements, naming of chemical molecules, IUPACs in nomenclature, this all is standard way. In order to standardize the stuff, we arrange elements in particular systematic order, and that's why we need to classify elements so that we can analyze the existing elements, we can study them very well, and moreover, we can also compare the properties and understand easily, right? So we have to classify elements for these three benefits on the screen, right guys? Are we clear about the necessity to classify? Yeah. And I'm sure you must be clear after watching the video. Yeah? Right? Yes.